Okay, next problem. Evaluate the integral over c z plus 1 by z square plus 2z plus 4, where c is the circle, modulus of z plus 1, I modulus of z plus 1 plus I equal to 2. See, our actual structure is in numerator some function of z, denominator is z minus a. In previous two problem we have denominator in the factorized form, that is z minus 2, z minus 3 and z minus 1 to z minus 2 whole square. But here in denominator I have a quadratic form. First I have to factorize this. So we know that just write down z square plus 2z plus 4 equal to 0. Apply the formula minus b plus a minus square root of b square minus 4ac. Finally arrive at z equal to minus 1 plus a minus I root 3. Okay, so how do you write the quadratic equation? Z minus first root and z minus second root. That is the main procedure. Z minus first root and z minus second root. Okay, now I have to verify which one is lies inside, which one is lies outside. Okay, minus 1 plus I root 3 is lies outside, minus 1 minus I root 3 is lies inside. See, how do you verify? As usual procedure. Okay, here I didn't mention. Okay, so how do you verify? Substitute z equal to minus 1 plus I root 3 here. The value is less than 2 lies inside, which is greater than 2 lies outside. Okay, so just verify yourself, otherwise now see my note 8. So we have modulus of z plus 1 plus I equal to 2. Okay, now I have to verify the point is z equal to minus 1 minus I root 3. What do you get? Minus 1 minus I root 3 plus 1 plus I have to compare with 2. So plus 1 minus 1 cancel. So finally I have 1 minus root 3 into I. So 1 minus root 3, what do you get? 1 minus na, you get 0.73. Okay, that is which is lesser than 2, so lies inside. The other point is lies outside. Okay, so now z minus 1 minus I lies inside, minus 1 plus I root 3 lies outside. So I have to keep the term z minus of minus 1 minus I root 3 denominator, then z minus of minus 1 plus I root 3 the numerator. Is similar to previous problem. So the term containing the point which is lies outside I have to keep in the numerator. So now write the formula, the simpler formula. F of z by z minus a dz equal to 2 pi a into f of a. Now compare 3 and LHS of 4. I will get f of z. F of z equal to z plus 1 by, just take minus symbol inside the bracket, z plus 1 minus I root 3 is, then also a value minus 1 minus I root 3. Now I have to verify a is lies in, I have to verify a lies inside and f of z is analytic. Clearly a lies inside, so already verified. How do you verify f of z is analytic? At what point f of z become infinity? Minus 1 plus I root 3. But minus 1 plus I root 3 lies outside. So clearly f of z is analytic inside and on C. Okay. So I need for finding answer I need f of a. So substitute in f of z equal to minus 1 minus I root 3. You will get f of minus 1 minus I root 3 is 1 by 2. My final answer is 2 pi a into f of a. 2 pi into f of a is f of minus 1 minus I root 3. So 2 pi a into 1 by 2. So finally pi a. So my final answer is pi a. So this is given integral. I can modify given integral as like this. Then apply the Cauchy integral formula. I have 2 pi a into f of a. My a is minus 1 minus I root 3. So substitute f of minus 1 minus I root 3. So 2 pi into 1 by 2. Finally I have pi a. So these are all two type of problem. So 2 a's are given. Both are lies inside. Apply the partial fraction. One is inside, one is outside. Take it into the numerator. So given the denominator in the form of factorized form, there is no problem. So what's a quadratic form? Quadratic polynomial form. Just factorize, and then when you factorize, you have 2 points. One is like verify both are lies inside, or one is inside, one is outside. Both are lies inside. I have to apply partial fraction. One is inside, another one is outside. So the term containing the point lies outside. I have to keep in the numerator. The denominator, the term containing the point lies inside. I have to keep in the denominator. Okay. Then apply the Cauchy integral formula. Finally, you can get the answer. Okay. Remaining problem, go through my notes. Okay. Whatever I work it out, please work it out yourself. Don't see my notes. First, before doing the problem, refer it. Then top to bottom, without seeing my note, you have to work it out. At some point you struggle, don't worry, go to my notes and refer it. But you have to start again in the initial step. Okay, so not in the middle. So starting in the start பண்ணனும், நடுவுல start பண்ணக்கூடாது. ஓகேவா? So in the middle just I introduce one more problem also. So already they asked 2 times in university examination this problem. F of a equal to integral of c 3z square plus 7z plus 1 by z minus a into f of dz. Modulus of z equal to 2. I have to find f of 4, f dash of 1 minus I, f double dash of 1 minus I. So by clearly Cauchy integral formula, my f of a means f of 4. Okay, f of 4, but z equal to 4 lies outside the circle C, because if you substitute z equal to 4, 4 is lesser than 2, so lies outside, so f of 4 is 0. What is for f dash of 1 minus I? Before that, when you compare this, my f of z is 3z square plus 7z plus 1. So just write the f of z, then find f dash of z, f double dash of z, substitute the point, finally you get the answer. This is 8-mark problem. Okay, very simple, only 3-line problem. Just write the formula, then compare it f of z. Okay, then substitute the value. 4 is lies outside, so 0. 1 plus is lies inside, so directly I can find f dash of z and substitute 1 minus I. Okay, as well as find f double dash and substitute 1 minus I, will get the answer. Okay, so please work it out. My homework problem also, at least university questions, because third is November 17, fourth is November 16, then fifth problem is April May 14, then sixth problem May June 15. See, sixth problem is a different one, because I have to apply another case of partial fraction. Okay, A, B, C. Just refer it. At least sixth problem, you have to do it. One more problem. At least you have to do homework problem. One is sixth problem, another one is any other problem. Okay, work it out and take a snapshot and send to me. Okay, so at least minimum you have to work all the problem what I worked in the notes, as well as 2 homework problem. One is 6th one, another one is your choice. Okay, because this is the most wanted problem. If you have any doubt, just take a video and send to me, otherwise voice message send to me, I will clarify you. So today we will finish Cauchy integral formula. Okay, tomorrow we will see Lorentz series expansion. After that, Cauchy residue theorem, then continuation type 1, type 2, type 3. One by one we will see it. Okay, thank you. Good night.